Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at the Math Methods Paper 1 2023 External Exam not multiple choice, short response in the tech-free section. Okay, so this video will be broken up into multiple parts because I don't think I'm going to be able to get through all of them today. But yeah, pretty much with this one here, you are pretty much just allowed the methods formula sheet and nothing else. You do get a bit of perusal time, but overall let's just get straight into it. If you have any questions about any of the questions I look at in the video, please tell me what question it is and try and timestamp it, and then I'll get back to you as soon as I can, okay? But let's get straight into it. So, for your multiple choice here. Here we go, question 11. So, two random samples, A and B, were obtained using two different Bernoulli experiments. Each Bernoulli trial in the random samples was recorded 1 for success or 0 for failure. The results are shown. In sample A, for each trial, the mean is 0.8 and the variance is 0.16. Okay, using the sample B's results to determine the mean and the variance for each trial in sample B. Okay, well, when I first actually read this question, I was completely confused because usually you don't have a table set up like this, but this is how we do it. Okay, so the mean of something, we're trying to figure out the mean of success. Okay, now if we have 1 for success and 0 for failure, we can literally see how much we have here and how many times we were successful. So the reason why this is 0.8 is because there was 10 of these, and 1, 2, 3, 4, 5, 6, 7, 8 were successful. So here, if we want to find the mean for B, so here this symbol is for mean. For B, we just have to go 1, 2, 3, 4, 5. 5 over 10, so that's the average. Okay, now Bernoulli means a binomial but n equals 1. So when we're calculating the variance for B, so I'm just going to variance for B, usually it's NPQ. So here P is the probability of success and Q is the probability of failure. N is the number of trials. In this case here, there's only one trial because it's a Bernoulli, so we have 1 times by probability of success. We had 5 that were successful, so it's going to be 5 over 10. And then the probability of failure means the complement of that, that means we have 5 over 10. So if we multiply those, that would give you 25 over 100, which would be 0.25. So that's the variance there. And that's how you answer question A. Okay. Again, a little bit confusing, but overall, not too bad. Okay. Let's head down to the next one. So compare the variability about the means of sample A and B. Okay. So basically what this means is, alright, who pretty much has a larger variance? Whoever has the larger variance has a larger variability. Okay, so here we can see the variance here for B was 0.25 and the variance for A was 0.16. So all we have to say is pretty much sample B's variance. Let's see if I can spell variance. Oh, it's just up here, isn't it? Yep. Variance was larger than A's, therefore B has more variability. I hate saying that word, so hard to say. Alright, all good. Alright, any questions about these ones here? Leave something in the comments, okay? Alright, question 12. The region bounded by the x-axis and the curve f of x equals x times by 4 minus x represents the plan of a garden bed. All the measurements are in meters. So pretty much this is going to be a garden bed, pretty much, okay? The estimate area of the garden using the sums formula, and we're given this guy here, where x1 is 1, x2 is thing, estimate the area. Okay, so breaking this guy down. Okay, what does this actually mean? Okay, so let's just zoom in for this guy. Because I think half the question is figuring out how to actually use this guy here. So this here pretty much means to add things up, okay? Now, we're estimating the area of the garden bed. Now here, this symbol here is representing the width of your little rectangles pretty much, okay? So we're estimating that garden bed. So what we're actually doing is basically we're going the y value multiplied by the width. So basically we're doing this. We're going that rectangle, that, and that, and something like that, okay? Where that would be your f of x, and that there would be your little change in x, okay? The I just represents place values you can put in, okay? So in the sigma, basically we're adding up the sum starting at I. So I could be pretty much 1, 2, etc. It has to be positive whole numbers. So we're starting at 1, and then we're going to 2, 3, and all the way up to 4. So here, when we're talking about this, so I, and we'll go f of x I, this guy here. Now here, for each of them, this little change in x, so this little, oh, I hate drawing the symbol. This just means a change in x. Literally just means, let's say you had x I plus 1 minus x I. So pretty much if we wanted the change pretty much for x, that would be like, let's say, x4 minus x3. That difference there, okay? Now the difference between all of them are going to be 1 because we're only making 1 increments, okay? So if I were to do, so the delta here for, let's say, x2 and x1, you can see x2 here is 2 and x1 is 1. So that difference is going to be 1. And it would be the same with each of them, okay? So back to this formula here. What this actually means is pretty much, alright, we'll go up to 4. So we're going to go pretty much, alright, f of x1 times by 1 plus f of x2 times by 1 plus f of x3 times by 1 plus f of x4 times by 1, where pretty much this represents each of these respectively, and the 1 for each of them represents this little change in x, okay? Now you can see I substituted in values for I, starting at 1 all the way up to 4, and that's pretty much what it represents, okay? So all we need to do is figure out actually what these guys are all the way up to there, and just add them all together, because they're all getting times by 1. So here we actually have our function. So f of x is x4 minus x. So here when we go x of 1, we said x of 1 is 1, so f of 1. F of x2 is f of 2. F of x3 is f of 3. So these are just the x values here. This isn't because that matches that. That's just a coincidence. I'm just literally just chucking in these values here. Okay. All right. F of 4. My apologies. F of 4. Okay. So now all we gotta do is just chuck in those values here pretty much. So here we'll start the first one. So f of 1, we'll put in 1 and then 4 minus 1. So that's going to give you 3. F of 2, that's going to be 2 times by 4 minus 2, which is going to give you 4. Then we'll have f of 3, which is going to be 3, 4 minus 3, which is going to give you 3. And then f of 4 will be 4 times by 4 minus 4, which gives you 0. So our area is going to pretty much be all these guys added together. Do we miss any of them? I do not believe so. Just double check my working here as well. Yeah, 4. Yeah, we're all good. Just double checking my working there. So pretty much we would have just 3 plus 4, which gives you an area of 10 approximately, okay? Alright, let's go down to the next one. Use a definite integral to determine the area of the garden bed. Okay, well this is pretty easy. So all we got to do is integrate from this value here to this value here of this function here, okay? So here that would be just the integral from 0 to 4 of x times by 4 minus x dx, okay? Now all I'm going to do is pretty much expand that expression before I integrate rather than doing a u sub, okay? So just expand that, so you get 4x minus x squared dx, then pretty much add 1 to the power divided by the new power, so 4x will turn into 4x squared over 2. X squared will be negative x, the negative in front, x cubed over 3, got the bounds 0 and 4, and we only need to chuck in the 4 because the 0 will make everything disappear in this case here, so it'll be 4 squared over 2 minus 4 cubed over 3 minus 0. Okay. Alright, now we just got to simplify these. So 4 times 4 is 16, times by 4 is 64. 64 over 2 minus 4 times 4, that's also 64 over 3. Okay, so we want to try and make them have a common denominator, or we want to try and simplify this a little bit. So here, make this let's try and make a common denominator 6. So we'll go times the top and bottom by 3 here, and times the top and bottom by 2 here. Alright, 3 times 64, okay? So just go 64, 64, that's 128, and then plus another 64, so that would be 192, okay? Remember, this has to be done without a calculator, so 192 over 6 minus 128 over 6. So here, what would that give you? That'd give you 64 over 6, I believe. 192 minus 128, is it? Yeah, 64. And then 64 over 6, we just think, alright, what do these guys have in common? They have a common number of 2, so that's the same as 2 times 32, and that's the same as 2 times by 3. And I think it can't be simplified any further than that. So that would be the area. That would be the exact area, and that's the approximate area. Okay. Alright. So let's take a look at this next one here, and we'll probably just do this for the next bit, and then we'll probably end the video there, and we'll do the second part, and then maybe a third part, depending how big this test is. At a certain airport, the departure of 1 in 5 international flights is delayed every day. The status of any flight is independent of the other flights. One international flight is selected at random each day for 3 days. Each selection is recorded either delayed or not delayed. State the 2 conditions that make this context suitable for modeling a binomial random variable. Well, for starters, you can break it into 2 things. You can break it into pretty much delayed or not delayed. You also have a probability of success and failure. The probability of success is 1 in 5, and the probability of failure, Q, is 4 in 5, okay, because of this stuff here. So probability that you do get delayed is 1 in 5, which we're going to say is success in this case here, and probability of not delayed is 4 in 5, okay. Calculate the actually, was there anything else we needed for this question? No, there wasn't, okay. Calculate the probability that at least 2 of the selected flights were delayed, okay? So pretty much what that means is we want the probability of 2 plus the probability of 3, okay? Because it's saying at least 2. So 2 is the minimum that could have happened, okay? So here, probability that x is equal to, what is it, r equals n choose r times by probability to the power of r times by q n minus r. That's our formula for binomial probability. So here, in this case here, we have n is equal to 3 because there is 3 days, okay? Not 5. A lot of people put 5. Our probability of success for delayed is 1 on 5 because they said delayed. And the probability of failure that you're not delayed is 4 over 5, okay? So we just need to chuck this information in the blue into our formula here, okay? So we'd have to work out each of them. So we'd have to work a probability of 2 and probability of 3. So let's do probability of 2 first. So probability of 2 would pretty much be 3 choose, in our case here is going to be 2 times by 1 on 5 to the power of 2 times by 4 on 5, 3 minus 2, okay? Alright, 3 choose 2, okay? So n choose r, n factorial over r factorial, n minus 1 factorial. Oh, not minus 1, minus r, okay? So here, when we're calculating this guy here, so 3 choose 2 would be 3 factorial over 2 factorial, 3 minus 2 factorial. So that's going to be 6 over 2, which is going to give you 3, I believe. Because that would be view 1, and that's 3 times 2. And actually, you could cancel out. straight away, but that's fine. Okay, so it's going to give you 3. So 3 times by 1 over 5, all squared, times by 4 on 5, just to the power of 1. Okay, just going to get rid of this now. Alright, now we're going to calculate this stuff here. So, expand that squared. So you have 3 times by 1 on 5, because that 2 would go there, that 2 would go there, times by 4 on 5. That's just going to be 1. So on the top you just have 12, and on the bottom you're going to have 25 times by 5 is 125. So the probability you get 2 is 12 out of 125. Now for the probability of 3. So it will be 3, choose 3, times by 1 on 5 to the power of 3, times by 4 on 5, 3 minus 3. That's going to be 1, and so with that, so this would just be 1 over 125. So the probability of getting at least 2 flights, aka the probability of 2 plus the probability of 3, will be 12 over 125 plus 1 over 125, which gives you 13 over 125. And that is the correct answer to this one here. Okay. Alrighty, so I'm going to split this up into the next part because I don't want this video being too long. The next part will start at question 14. Okay. If you have any questions about question 13, 12, and 11, leave something in the comments and I'll try my best to answer it. But I'll see you in the next video.